Welcome to Brain Vision.
Hello friends, as shown in the figure, two rotating rods in a vertical plane are connected by the slider block P of negligible mass. The rod attached at A having the mass of 0.8 kg. The mass of AE here we write 0.8 kg and its length is 160 millimeter, that is 0.16 meter. Mass of BP rod is given 1 kg and having the length 200 millimeter, that is 0.2 meter. The friction between the block P and AE is negligible. The motion of the system is controlled by applying the couple on var AE. So M applied on AE it is given that angular velocity of rod BP is 20 radian per second in clockwise direction and angular acceleration is 80 radian per second square in clockwise direction. We have to calculate first part, moment applied at A and component of force exerted on AE by P. Exerted by P on AE. Let us start solving it. First, write the position vector of different points. Position vector of PA is 0.2 sine of 30 downward, that is 0.1 meter in downward direction. Position vector of P with respect to B is 0.2 meter down to the horizontal line by 30 degree. Position vector of E with respect to A is downward by 0.16 meter. Kinematics. Angular velocity of BP is 20 radian per second in clockwise direction and angular acceleration of BP is 80 radian per second square in clockwise direction. Velocity analysis. Rod BP. Velocity of P is defined as cross product of angular velocity and position vector. Angular velocity of BP cross position vector of P with respect to B. Substituting the value, we will get 20 into 0.2 meter up above the horizontal plane y angle 60 degree. So we can write velocity of p point to be 4 meter per second in the direction up above the horizontal line by 60 degree. Rod AE use a frame of reference rotating with angular velocity omega AE to be omega AE in clockwise anti-clockwise direction. The collar slides on the rod with relative velocity of P with respect to AE is U in upward direction. So velocity of P can be written as velocity of P dash plus velocity of P with respect to AE. Velocity of P dash is defined as cross product of angular velocity and position vector. So AE cross RPA vector plus U. So it can be written as velocity of P you will get 0.1 angular velocity of AE towards right plus U in upward direction. Equate the expression for BP using triangle construction for vector addition. This is U vector. This is BP vector. And this is minus 0.1 omega AE, that is 4 meter per second. So we can write minus 0.1 omega AE is equal to 4 cos of 60. So angular velocity of AE we will get 20 radian per second in clockwise direction and U is equal to 4 sine of 60, that is 3.41, sorry, 461 meter per second. So you can say velocity of P with respect to AE having the value 3.4641 meter per second in upward direction. Now we will do acceleration analysis. Rod BP, acceleration of P can be defined as cross product of angular velocity and position vector, and omega square BP RPV vector, substituting the value 80 radian per second square into 0.2 meter in the direction shown in figure plus 20 square 0.2 meter in the direction up along the horizontal line by 30 degree. So acceleration of P point would be 16 meter per second square in the direction above to the horizontal line by 60 degree plus 80 meter per second square in the direction above the horizontal line by 30 degree. Rod AE, angular acceleration of AE is alpha AE in counterclockwise direction, and acceleration of P with respect to AE is derivative of U in upward direction. So acceleration of P can be written as AP dash plus acceleration of P with respect to AE plus twice of omega AE having the cross vector with velocity of P with respect to AE. Here AP dash having the value alpha cross AE vector with PA minus omega square AE into position vector of P with respect to A. Substituting the value, we will write 0.1 into alpha AE in the direction of right plus 20 square into 0.1 in vertically upward direction. So acceleration of P dash you can write 0.1 alpha AE towards left plus 40 upward meter per second square. Value, calculating the value of omega cross AE into velocity of P with respect to AE. Here you have to take the cross product 2 into 20 into 3.4641 towards right, so it will be 138.564 towards right meter per second square, equating the two expression of acceleration at p and resolving into its component. Equate the two expression for acceleration at p and equating or and resolving into its component. So if we take horizontal component right direction to be positive, it will be minus 16 cos of 60 plus 80 cos of 30 is equal to 0.1 alpha AE plus 138.564. So from here, angular acceleration of AE we will get 772.82 radian per second square in clockwise direction. Now, mass, weight and moment of inertia. Mass, weight and moment of inertia. Mass of AE is given 0.8 kg. So weight of AE will be 0.8 into 9.81, that is 7.848 Newton. Mass of BP rod is given 1 kg. So mass of BP rod will be 1.0 into 9.81 Newton. Now moment of inertia of the rod AE about its center of mass. One by 12 mass of AE into square of its length. Mass is 0.8 kg. Length is given 0.16 meter. So its moment of inertia we will get 1.70667 into 10 to the power minus 3 kg meter square. Similarly, moment of inertia of BP rod about its center of mass, that will be the same. So I am writing directly 1 by 12 mass of A is 1 kg, length is 0.2 meter. So moment of inertia having the value 3.333 kg meter square. Let mass center of AE is G and BP is H. So position vector of G with respect to A having the value 0.08 meter vertically downward, and that of H with respect to B is 0.1 meter down to the horizontal line by 30 degree. Now acceleration of mass center, acceleration of G can be written as cross product of angular acceleration and its position vector. So alpha AE cross RGA vector minus omega square AE into RGA vector, that is 7.772.82 into 0.08 towards left plus 20 square into 0.08, where upper unit will be meter per second square. So acceleration of G, we can write 61.826 towards left plus 32, upper unit is meter per second square. Similarly, acceleration of H will be cross product of angular velocity of BP rod and position vector of H with respect to A minus omega square BP position vector of H with respect to B. So this is also with respect to B. Substituting the value 80 into 0.1 in the direction 60 degree above horizontal line plus 20 square into 0.1 above to the horizontal line by 30 degree. So acceleration of h we will get 8 meter per second square above the horizontal line by 60 degree plus 40 above to the horizontal line by 30 degree. Now we will calculate inertial term at mass center. For rod AE, mass of AE into acceleration of center of mass of AE. So it is 49.460 towards left plus 25. I have written here directly. You may simply calculate by simple multiplication is there. Similarly, BP rod having mass of BP into acceleration of h. So this value will be 8 in the direction 60 degree up along the horizontal line and 40 Newton. Effective couple at mass centers. We can measure effective couple about the mass center. First, for AE rod, it will be moment of inertia into AE into angular acceleration. So it will be 1.3189 Newton meter in clockwise direction, and off rod BP, it will be moment of inertia of BP rod into angular acceleration. So that you will get 0.2667 Newton into meter in clockwise direction. Now we have to draw the free body diagram of AV rod, sorry, FVD of AE rod and BP rod. First we will draw AE rod. This is A point, this is E point, this is P. Here reaction at AX and AY. This is the center of mass. So here weight of AE will act. It will experience force due to its motion, mass of AE into acceleration of G, and due to rotation IAE into alpha AE. Now we have to analyze taking moment of force about A point. So it will be minus 0.10 into P to be minus 0.08 into 49.460. This value already we have calculated, minus 1.3189. So value of P from this equation you will give you 52.757 Newton. Now we will discuss for BP rod. This is BP, P point, B point. This is the direction of P. This is its center H. So here its weight will act 9.81 Newton. It having the couple M, B, Y and Vx. Here the force of 8 Newton will act, and in this direction force of 14 Newton will act, and it will rotate with angular acceleration alpha, that's I into alpha, which having the value 0.2667 Newton into meter. Now finding moment of couple about V point. We will get 52.757 into 0.1 plus 9.81 into 0.08663 plus M is equal to minus 8 Newton into 0.1 minus 0.2667. So on solving M you will get 7.1919 Newton meter. So we can write the final answer of this couple having the value 7.1919 Newton into meter in clockwise direction, and P having the value 52.8 Newton towards left. That's all for it. Thanks for watching it.